Hello class, we're going to be working on chapter 2.6, solving inequalities by adding and subtracting. First of all, we're going to start out with just graphing some inequalities that they ask you to graph. I am going to jump ahead to this part of the lesson, so if you can find this for me, please. Big questions you need to ask yourself are, do I use a closed circle or an open circle? A closed circle is going to require an equal sign, or a less than or equal to, or a greater than or equal to sign. An open circle is if you have just a greater than or a less than. And the second question you'll need to ask yourself is, do I shade the graph to the right or to the left? To the right is for greater than, to the left is for the less than. Now let's go back to our first examples. If I look at example A, I note that I have x less than 3. The first question, open circle or closed circle. There is no equal sign underneath the less than sign, so that indicates I need an open circle. The second question, do I go to the left or do I go to the right? Well, I want everything that is less than 3, so I am going to go to my left, because if I look at it, 0, for example, is less than 3. And I fill this in. Make sure you also go through cover over the arrow as well. Now let's look at B. B is less than or equal to negative 3. The first question, do I use an open circle or a closed circle? This inequality has an equal sign in it. It is less than or equal to. Therefore, I'm going to use a closed circle. The second question I always ask myself, do I want to go to the left or do I want to go to the right? I want everything that is less than negative 3. If I would go to my right, I'm going to go to 0. Well, 0 is greater than negative 3, so I'm going to go to my left, because that would encompass numbers like negative 4, negative 5, etc. At this point, please hit pause, and you try C, D, and E. Let's see how you did. In C, I'm going to have an open circle, and I will shade everything to my right because it's greater than. In D, I will have a closed circle at negative 4 because there's an equal sign. I want greater than, so I'll be graphing everything to my right. E is a little bit trickier. It just says W equals 5. That is a closed circle at positive 5. And I hope you did well with those. Secondly, I'm going to write an inequality from a graph. Now again, I can still ask myself the questions. Do I have a closed circle or an open circle? And on A, I have an open circle. Did they shade everything to the right or everything to the left? Well, they shaded everything to the left. So n is less than negative 3. If I look at B, first of all, do they have a closed circle or an open circle? It's a closed circle. Did they go to the left or did they go to the right? They went to the right. So n is going to be greater than or equal to 2. C is only the point negative 1. Therefore, n equals negative 1. The next part of the lesson is a review of what we did last year in 7th grade, solving an inequality. The same concept of using inverse operations in solving equations can be used to solve inequalities. So you're going to note that this is very much like solving equations. Y plus negative 6 minus negative 6 is greater than or equal to 2 minus negative 6. I have to pay attention to add the opposite. So y is going to be greater than or equal to 8. Most often we'll be graphing these. We usually put in 0, 8, and negative 8. And then you would be using a closed circle and graphing everything to your right. In B, most students don't particularly like that variable on the right side, so you may change it around. However, you've got to be very careful. Notice that the open end of the inequality is pointing to the -3, and the pointy end is pointing to the n minus 1. When I rewrite this, I have to change the direction so that the opened end is still to the -3 and the pointed end is still to the n minus 1. Now I can go through and solve. Adding 1 to both sides, n is going to be less than -2. And to graph that, this time I'll use an open circle, and I want everything less than. So I'm going to go to my left. You can also kind of reason these out too. Try a number that's less than -2. Take, for example, -4. -4 minus 1 is, well, let's try -5. -5 minus 1 is going to be -6, and -6 is less than -3. Or you can just use following the direction of the inequality symbol as well. Hit pause at this point, and you try C and D, and I'll show you how to work them. I'm going to rewrite it as W plus 4 is greater than -2. I feel more comfortable, just like everybody else, with that variable on my left. Remembering to add the opposite, I will have W is greater than -6. To graph that, -6, 0, and 6. I'll have an open circle, and I want everything greater than -6. And if you try one of the numbers, that'll make sense. If you try 0, for example, 0 plus 4 is 4, and 4 is greater than -2. On the other hand, if you tried a -8, -8 plus 4 is -4. -4 is not greater than -2. In D, I'm going to rewrite x plus 12 greater than or equal to 1. Again, noting, open end of the symbol is toward the x, of the inequality symbol is to the x plus 12. The pointed end is toward the 1. Now I can solve. And add the opposite, so I will get a -11. To graph that, I'll have a -11, a 0, and 11. It's just the way we usually do it. I'll put a closed circle at the -11 since there's an equal sign in here. And I want everything greater than that because, again, if I use 0, 0 plus 12, 12 is greater than 1. If I tried something smaller than -11, like say -12, I'm going to get 0, and 0 is not going to be greater than 1. This might be the more confusing part of the lesson, to go through how to write an inequality for a word sentence. Sometimes they're very straightforward. Y is less than 5, which should be Y, obviously, less than 5, or M is greater than -3. The greater than or equal to and the less than or equal to get a little more confusing because there's just a few more clue words. W is no more than 8. So 8 is the greatest it can be, therefore it's got to be less than 8. W is at most 8. Again, 8 is the biggest number it can be, so obviously you want something less than 8. Same thing with maximum, same thing with is no greater than. On the other hand, if you have x is no less than -4, that means it has to be bigger than -4 because -4 is the smallest it can be. Same thing for x is at least -4. -4 is the smallest it can be, so you want it to be greater than or equal to. And obviously if maximum is less than or equal to, minimum has to be greater than or equal to. Now, here are some examples. R is more than 9. R is greater than 9. X is at most negative 7. Well, that fits with our less than or equal to, because the most it can be is negative 7. If v has a minimum of 5, then that means 5 is the absolute smallest number it can be, so we want something greater than or equal to 5. 2.5 is less than p, is less than p, and 0.9 is no greater than k. Is no greater than is a less than or equal to. And that concludes lesson 2.6, Scouting Out.